structures.
We need to make, I'm just kidding.
Are you going to talk about that?
If people are interested in what this might be, we'll talk about it on the next one. First we have to see if it works. If you have a bad back, you might want it. Anyways, let's look at what matters. We have completed and actually tested the BRZ rear upper control arms. And this is one of those projects and one of those control arms that I think I needed several years of furthering my experience with design in order to come up with something that's actually what I feel is the best version of what could possibly be created on the market out of any company that's ever done it. There are several options out there available for the rear uppers, and none of them are any good. And this is not my opinion, this is based off of feedback. So what everyone usually defaults to is running the OEM upper. And the reason why you may want to run an adjustable upper is due to these axles on this car specifically are prone to failure, and that's usually because we're adjusting the alignment from the lowers only, meaning the plunge length of the axle is not able to compensate. So if you're able to go in with the upper and out with the lower versus just out with the lower, you're gonna have the correct axle length all the time. So I'll show you the design process and concept around this. Man, I had so many adjustable versions of every single possible method of adjustment in this file until I finally landed on what you see here. When compared to the actual chassis, we have the OEM upper, which is here, OEM subframe, frame rail, and control arm. I'm gonna hide the control arm because you can kind of see what that looks like. And this is what I had come up for the design. So it clears all the exact same travel range, but what you'll notice is this is the, oh wow, this is the axle hump here, and the center of the diff comes out right in this area. So the issue was the axle comes through and actually contacts the OEM upper right on this rib, and then this pocket is also meant for an axle, so it comes right across here. So what I did was add this extra bend and widen up the arm in this area so the axle comes through and clears absolutely everything at all ranges. So the axle's never gonna run into the upper, even if you relocate the diff. The on-car adjustability of this arm, covered by Joel, how easily it is to install and take in and off and adjust is really, really good. The factory sensor is able to easily bolt there. The OEM one had holes, and we just added zip tie slots. Other thing to consider is like how easily can you build this control arm? Each bend is the exact same angle. So we only have to set up our brake press once and we can bend all of these. Plus we have points of reference that can be easily bent and then ground off after bending. That gives it a really nice clean look. Most importantly, we have a uniball on the outer. The A-arm is the point at which the knuckle and everything else rotates around. So making sure you have a really solid ball joint that doesn't want to move at all on the outside of the arm is really, really important. So that covers the rear upper, and we did test it, raced it, used it. Really happy with how it all went. Next thing was an absolute out of this world idea. I found out that the BMWs use the exact same, I actually knew this a long time ago, but the BMWs use the exact same stud on all 3 points of every knuckle made after 2008, maybe even earlier. Starting with the E80 and then E90, and then you can go to the G body, the F body, and everything in between. They all use this cupped seat, straight M16 millimeter stud, and then a 14 millimeter thread. So when I noticed that the outer ball joints of the tie rods are relatively the same size, slightly stronger built than the actual control arm itself, I thought I could come up with a way to make that into a control arm. And I successfully did that after a ton of trial and error in design. And of course, this now looks simple to you guys, but it took a long time to get to this point. So I'm basically going to recreate this out of a much stronger material. The coolest part about what I have here is that I've created an on-car adjustable control arm that can be used for any lower on any BMW of any generation after 2008, any chassis, I should say, after 2008. And it's also on-car adjustable, and it accepts our standard hardware. So the cool part about this whole thing is I'm going to be able to crack this loose with an Allen key, spin this body on its own, and actually lengthen and shorten the control arm. And then when I go to retighten this to what is an outer tie rod, I can now clamp the bolt with the factory pinch bolt from BMW, and this thing is not going anywhere. And it is equally as strong as any OEM arm. It's got a fully sealed and OEM engineered ball joint with our adaptation, which converts the bushing into a bearing and gives you the camber adjustment that you need. So I believe that for race car guys, this is going to be a big deal. Not so much for drifting. We tend to replace the whole lower control arm and convert it to a one piece, but this is something that's on the car right now. It's being tested, and it works really, really well. So that's cool. That's this here. And basically I had a number of designs on the end of this in order to come up with that. Another cool thing, we're gonna get to this. This is really cool stuff here. Okay, so leading into this, you can kind of see how that outer tie rod is used here. This is actually a G42 front end, but very much the same as A90 Supra, F20, F30, F44, G42, G82, all the things, all the stuff, all the bodies. BMW is single-handedly keeping rear-wheel drive performance cars alive. Single-handedly. They have more than 10 different versions of chassis of all various sizes. It's really impressive. But if you're ever curious how these dual ball joint setups look and work, this is it right here. We have the dual action of these ball joints. It's basically got variable caster, variable scrub radius. Your toe and your Ackerman and everything is and your roll center, all of it is dictated by the position and location of all of these ball joints, and they all work perfectly together on a BMW. It's got a little bit of bump steer, but that really depends on the starting ride height as well. Really, really cool how all of this stuff works. And I'm excited to make more and more parts for these. Now, assembling these takes a lot of experience and skill and practice. So if you're wondering how these meshes and stuff are all constrained, it takes a lot of time, and took a lot of it not working that great for it to then work great. And there's nobody really to tell you the perfect way to do this. It just has to be in a way that makes perfect sense. Let's go on to what I've been working on a bunch, and you're gonna see all of these parts installed on the video after this one, where we actually have all of these cut and welded already. Joel's gonna be taking care of the majority of that, but basically I took a bunch of scans of a bunch of rear knuckles. I think it's an F30, a G42, a E80, and an E90, and one other knuckle. And essentially BMW held all the points in the same spot on all of them, but some are aluminum, some are steel, and they have different caliper mounts based on M and non-M and all of that stuff. So basically I got on this really interesting path where if I change the rotor size, which is this rotor here. This rotor, I'm not gonna say which one it is yet, but it has the exact same dimensions as a rear rotor does, but it's all different. It's a shallower rotor. It's a different offset. Basically what that allows for is more room to put bracketry and stuff. So I was successfully able to create a dual caliper bracket while creating a roll center corrected bracket. And this, surprisingly, is really easy to build because the factory knuckle acts as a jig, and it's really affordable and cheap to build, but it gives you all the benefits that a full grip kit would give you, all within the factory knuckle. Now the factory knuckle has benefits because it's got the factory ABS sensor, it's got the factory everything. Everything's gonna fit perfectly, and it keeps costs down and performance high and reliability high. So using this rotor allowed for the clearance to put in this bracket, and we were also able to run dual Willwood brackets as well, which is even crazier. We have that here. So this is a Willwood bracket that bolts to the bracket using the caliper bolts, and then it's able to hold dual Willwoods, which I'll get in place here. So now I have a rear grip kit using a stock knuckle. It can mount 2 Willwood calipers, or it can mount 2 OEM calipers. And then we can hide this Willwood bracket. And now we have mounted successfully dual OEM calipers, all while maintaining the ABS area. This is like crazy. I wouldn't say lucky, but I was trying to do this, but then finding the right rotor. It is the front rotor from a different BMW with all of the same dimensions. So we're testing this out tomorrow. I ordered the rotor last week, getting it tomorrow. We're gonna see how all of this works, because we have all of this done already. We just need to check it.
Well, the rotor fits now that I drilled it. I'm about to mock up the calipers though. Fits so good. But does the other one fit?
It fits
What fits?
the rotor
No way.
with the calipers.
You sure?
Yeah, come check it.
Does it fit? Oh, don't look yet. It's almost done.
He came and got it.
Just
I was too excited.
Zach, I was trying to. It's not even done yet.
Yeah, but how well does it?
It's perfect, obviously.
No, that's not usually. Ask Donnie how.
It simulates.
Ask Donnie how obviously that
Well-
should be. He would say about 80%.
Let me tighten this caliper, and then I think it's pretty close to center.
So what I calculated was that the sheet thickness needed to be 0.265 of the plate. This is 0.25. But when we go to the alloy material, it usually comes in a bit thicker. So I think it'll be perfect when because that's a mild steel plate right on here. This doesn't hit the ABS. Oh, it clears that block too for the parking brake. Just did you check that?
Man, I haven't even finished tightening the bolts, and you're already out here asking me so many questions.
Pretty mature. But basically, you're just going to run a spacer between the OEM knuckle and this bracket. And then when I started getting into the differences in knuckles, this one is it's a newer BMW, and it holds a larger brakes and stuff. So very similar bracket, and the only downside is that I couldn't fit an OEM caliper as the secondary, but I still could fit a Willwood caliper as a secondary. All I needed to do was run the exact same bracket, and you can't see it, but it has all the exact same geometry correction points. And then I just needed to add this shim, and now using that same rotor that I mentioned, we are able to run a Willwood secondary, and then we can still use an OEM primary, or I could have dual Willwoods. So we're kind of like uncovering all these possibilities, and because I changed the rotor to something that has the same center bore and everything, it's from a BMW, it opened up the possibilities of like very affordable brake caliper packages, dual caliper brackets, and making your chassis into a roll center corrected, geometry perfected grip car. This is also good for racing or for drifting. So it's a really interesting path to go down, and it's been pretty sweet. And I do have proof of everything that I just said with my simulations. We have successfully simulated our grip one, which you can see here has all of the adapted brackets. And we do have the wheel well in here, so we can reference, make it visible on both. So yeah, you can see that they're basically the same alignment at the same height. It's not exactly. Do you think just keep talking? Sounds like you got it. So we're going to compare the same ride height, and you can see that I have a scan of the wheel arch. We're gonna hide that because that kind of takes away from everything. But that just gives you reference of wheel center, wheel position, wheel height. I made this makeshift axle center line, what it does is just exaggerates what's happening with the wheel, and gives you a good visual representation of like everything. So anytime I try to visualize something, I always extend it beyond the extreme so that it really emphasizes what it's doing. And you can also do that with all of these control arms and run axis lines, and that's how we measure all of our anti-squat, camber gain, roll center, anti-dive, all this stuff. But for the sake of visual representation, we are simply going to match the ride height. So let's go for a good reference. Basically, a good starting point is probably with this just below the subframe line here. And you can see that through travel range, let's go from here to here. What we're going to be looking for is, what is our camber curve? What is our roll center? That's the angle of all of these control arms. What is our anti-squat? That is the angle of our traction arms. And how do they all behave at this range of travel? This is likely the range of travel that we're going to see on a drift car. If you've seen any of our suspension displays that we make a roll center one for multi-link, for double wishbone and McPherson. You're going to see that all of these lines, if extended beyond just what you can see here, the converging lines are going to start creating our roll center, and that is what's going to determine how the rear of this chassis is going to behave. And we can definitely see that with this one as the roll center corrected, that we are in a very good range of where our control arm angles would want to be. And if I switch over to the original, I can start at the same height. So already we can compare control arm angles. If I put the center line just below the subframe here, and I put the center line just below the subframe here, let's just take a look at these control arm angles, and we can kind of visualize where these would converge. And there's a big difference between the roll center corrected one, which is this one, and the OEM one, which is this one. And if I go to the same ride height, which let's put the center line just at the edge of the subframe here, look at all these control arms. We basically have negative anti-squat. We have no roll center. It's going to be passing through the pavement. We're going to have a lot of body roll because of this. And we're not going to have a whole lot of mechanical control over this wheel. And then if we go to the same height with our grip kit, we're basically at the same angles as the original suspension, but when the original suspension was down. So that is the entire point of roll center correcting all the geometry. And we've also done a couple of additional things, like allowing for bump steer adjustment on the toe pickup. And we did do some multi options for, we can adjust our camber gain. Sometimes camber gain is something that's not necessarily a bad thing, especially in road racing. We may want to maintain some of that. So depending on the range that we set the ride height at on this car, we're still going to get similar to factory camber gain. And you can actually see that we are getting, at this very extreme limit, we may never see this much. Yeah, like we're way above the body line. So we don't really concern ourselves with what the tire is doing up in this range. This is the range that we care a lot about, is right around here. And if we do the same location with the OEM knuckle, no corrections, there's just a lot of issues. Although I will say the OEM suspension simulates better, and that isn't because it works better, it's because there's way less parts. I have the entire grip kit model in here with all of the actual adjustable control arms. So that is why this model is a little glitchy, because we actually have, I can hide all these, we actually have all the full assembled bodies in here. The simulations don't like that many components. So needless to say, this is everything that I've been working on over the last little while. A lot of cool stuff. I'll give you a quick visual on what this looks like on the car and how it does actually work better. And next week, or end of the whatever, Joel's gonna be going over all of this stuff, which is really cool. From this, we're going to be creating a full knuckle, of course. But that full knuckle is going to be part of a different package that I do want to still maintain the ability to run OEM lowers and traction arms, because generally over all of the BMWs, they typically have used the same arms there. So we can make an adjustable set that will work for a grip kit or for OEM, because I want to serve the road race guys as well as the drift guys. But the upper arms and all the other stuff, we're going to be making as part of our control arm package that will go with that grip kit. So I'll show you the control arm and then that's pretty much it. You gonna show them this?
Oh yeah, I was just drawing up a different one.
A different one, bigger?
No, with the tapered angle
Okay.
that you suggested.
This is to keep the tow arm bolts from falling off of the rush cars. Basically what we've determined is that the thickness of the aluminum on the knuckle is too much for the small bolt to overcome and compress. So the torque of the bolt actually never tightens on the ball joint, and this bolt comes out. It's come out on us twice now. Basically, if you drive the car for one day, that bolt's coming out. We are making a 3D printed safety cap that will actually clip over the knuckle, press up against the bolt, and we don't need this to put in a bunch of work. We just need it to keep the bolt from falling out of the knuckle. If the bolt comes loose at the end of the day, you can still retighten it here through this hole, but this will keep it at least attached to the car. That's really what we care the most about. So he's modding up that. You making that angle? Like,
Yeah, add a little bit of flair to it, keep tension on it.
so in 3D printing world, so many little things matter. Like he drew these corners at 90 degrees, but if you draw them at 89 degrees, when you clip it on and it sits at 90, it's actually gonna have that very slight amount of pressure to keep these catches engaged. All these tiny, tiny little things that you wouldn't think of in reality. Same thing if you make like two parts that are 3D printed insert into each other, you never make them square edges, you actually add a slight angle, just like you see with Tupperware containers and basically anything. Like, you wouldn't think about it, but everything has a slight taper to it for that purpose alone. If you come over here, we have my arm on the car. I made this slightly longer after this 3D printed version, but this arm is quite a bit wider here, and it actually contacts the knuckle often on this corner. And this, because of how much lower profile it is right here, it actually gives us a bunch more clearance to the knuckle. So we've made an improvement on clearance. We're able to maintain, like I said, OEM reliability. These babies are good for 80,000 K or more, while still getting the benefits of a uniball or a Heim joint over a bushing, and we can get the camber out of the car at the lower half, which is better than getting it at the top for race guys, because they want to fit larger wheels, they want to get more camber, they want to get more track width. And the only way to do that without doing these arms is cambering in the top, which if you're trying to run a big tire and clear more, you can't go in more at the top. You're going to run into more stuff. And then on this side, we made the eccentric uniball, so we don't necessarily need to do a full adjustable arm on the tension arm because we are able to rotate that and get that out pretty far. So this is all cool stuff. This is more racing than it is drifting, but it does still work for drifting if you ran our mini kit. And then the cost of this, really, it's not going to be nearly as expensive as making an entire arm, just because it uses the majority of the bulk of it is actually an OEM outer. So that's it for today on Design Time. There was way more things that we did. We should have done probably 2 episodes between. Maybe we'll get you guys caught up, but it's been real busy, really fun, lots of prototyping, racing, testing, and things are going well. So see you guys on the next episode. That's it for now.